A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Alright, here's what Daniel sent us this week. He's asking about Claude's latency problem. Specifically, how you'd actually measure it objectively, whether Anthropic offers any real SLA guarantees on enterprise tiers, and how those compare to standard compute SLAs across the rest of the industry. And the subtext here is pretty pointed. Are developers being asked to build production systems on infrastructure that would get laughed out of any traditional cloud procurement meeting?
Oh, this one's been sitting in my head for weeks. Because the answer to that last question is basically yes, and the reasons why are genuinely fascinating from a systems design perspective.
I should mention, today's script is courtesy of Claude Sonnet 4.6, which is a delightful level of recursion given we're about to spend 25 minutes complaining about Claude's latency.
The model generating the script about its own slowness. There's something almost philosophical there.
Or just ironic. Let's start with the measurement question, because I think this is underappreciated. When people say Claude is slow, they're usually gesturing at a vague feeling. What does slow actually mean in a way you can put a number on?
So the inference community has converged on 5 core metrics, and they each capture a different dimension of the problem. The first is TTFT, time to first token, which is the delay between sending your request and seeing the first character appear. For interactive chat apps, this is the dominant metric. It's what determines whether the interface feels alive or frozen.
And that's separate from how fast it actually generates the response?
Completely separate. The second metric is ITL, intertoken latency, the time between successive tokens once generation has started. Then you have end-to-end latency, which is the total time from request to final token. That's what matters for batch pipelines. And then throughput metrics, tokens per second for generation speed, and requests per second for concurrency capacity.
So a model could have terrible TTFT but decent generation speed once it starts, or vice versa.
Which is exactly the pattern you see in the benchmarks. And here's the thing most people miss when they're evaluating model speed. The median is almost meaningless for production systems. What you actually care about is the P95, the 95th percentile. If your median TTFT is 1 second but your P95 is 4 seconds, roughly 1 in 20 requests feels dramatically slower than what you tested in your demo.
And in a system handling 1,000 requests an hour, that's 50 bad experiences per hour.
50 requests per hour where your user is staring at a frozen screen for 4 seconds instead of 1. There's a benchmark from March this year. A software engineer named Kunal Ganglani ran a pretty rigorous head-to-head across 5 models, 3 prompt sizes, 3 runs each. And the finding on Claude Sonnet 4 was striking. Median TTFT on long prompts, 1,216 milliseconds. P95 TTFT on the same prompts, 4,288 milliseconds. That's 3.5 times the median.
3.5 times. At P95.
And Ganglani's framing of it was exactly right. He wrote that high P95 variance is what generates user complaints, not the median. You can have an acceptable average and still have a product that feels broken to a meaningful percentage of your users.
How does that compare to the other models in that benchmark?
Dramatically different. GPT 4.1 on long prompts, median TTFT 1,670 milliseconds, P95 1,833, so the P95 was about 10% higher than the median. Gemini 2.5 Flash, median 1,885, P95 2014, basically flat. Claude Haiku 4.5 was actually the best performer in the whole test, median 610 milliseconds, P95 843. Tight spread, fast absolute numbers.
Wait, so Claude Haiku is the fastest model in the benchmark, faster than OpenAI and Google.
On TTFT, yes, in that specific test. 597 milliseconds on short prompts. That's the fastest of any model tested. The latency conversation almost always focuses on Sonnet and Opus, but Haiku 4.5 is genuinely fast. The problem is, it's not the model most enterprise customers are defaulting to.
So Anthropic has a fast model, it's just not the one people are actually using for serious work.
That's a real tension in their lineup. And then at the other end, there's a bench LM speed leaderboard. They pull data from artificial analysis. And, as of earlier this month, Anthropic as a provider averages 52 tokens per second and a 3.3 second average TTFT. For context, NVIDIA Inference is at 260 tokens per second. Mistral is at 126. Even DeepSeek at 48 tokens per second is in Anthropic's neighborhood.
So Anthropic is near the bottom of the provider speed rankings.
Second slowest by tokens per second. And there's an important caveat on OpenAI's numbers. Their average TTFT looks terrible at 42 seconds, but that's heavily skewed by O3 and O4, which are reasoning models that literally think before responding. Strip those out and the comparison looks different. But for Anthropic, there's no comparable asterisk. The flagship models are just slow.
Okay, so we've established that the slowness is real and measurable. Now, why is it happening? Because I want to understand the infrastructure reality before we get into the SLA question.
The peak hour problem is the most visible symptom. In late March, an Anthropic engineer, Tariq Shihipar, who works on Claude Code, posted on X that Anthropic was adjusting session limits during peak hours, 5 a.m. to 11 a.m. Pacific, which is U.S. business hours. The limits were being consumed faster during that window. About 7% of users were hitting caps they wouldn't have hit before.
And this was announced by an individual engineer on X, not through official Anthropic channels.
That's the detail that should make enterprise procurement teams uncomfortable. A change affecting paying customers, Pro and Max subscribers, not just free tier, announced informally on social media. Not a status page update, not an email, not a changelog, an engineer's personal post.
Meanwhile, 2 weeks earlier, Anthropic had run a promotion doubling usage limits during off-peak hours,
which is a classic load balancing move. You're incentivizing users to shift their usage to times when your GPU clusters have idle capacity. GPU infrastructure runs 24/7 whether you're using it or not, so filling off-peak hours is basically free capacity. The new stack analyzed this as a dual-purpose play, smooth out the traffic curve, and generate goodwill with a thank you framing. But here's the telling detail. That promotion applied to Claude's app surfaces, web, desktop, mobile, Claude Code, not the API.
so the developers actually building production systems got nothing.
The people most affected by latency and throughput constraints got excluded from the capacity relief. That's a deliberate product decision. And what it signals is that Anthropic's priority in that moment was consumer ecosystem lock-in, not API customer relief.
Let's get into the SLA question then, because this is where it gets really interesting. What does Anthropic actually promise?
For standard tier, which is every API user by default, the answer is nothing. No uptime guarantee, no latency guarantee, no throughput guarantee, no throughput guarantee. The API docs are explicit. All rate limits represent maximum allowed usage, not guaranteed minimums. The standard terms say Anthropic does not guarantee uninterrupted service. You're on best effort infrastructure with no contractual recourse.
Which is fine for a side project, but is a genuinely alarming basis for a production system.
And the Reddit consensus in the enterprise communities reflects exactly that. The framing you see repeatedly is, from Anthropic, there are no SLAs, no guarantees of service. Full stop.
So what's the priority tier?
Priority tier is Anthropic's committed use product. You contact sales, you commit to a specific number of input tokens per minute and output tokens per minute for 1, 3, 6, or 12 months. The pricing isn't public. In exchange, you get one thing contractually, a target of 99.5% uptime with prioritized computational resources. That's the only performance commitment.
What about latency? What about TTFT?
Nothing. No latency guarantee, no TTFT guarantee, no minimum tokens per second. What priority tier actually does is prioritize your requests over standard tier requests during peak periods. You're buying a place at the front of the queue. If Anthropic's infrastructure is running slow, you're slow too, just less likely to get a 529 server overloaded error.
So it's queue priority, not performance.
That's the critical distinction that I think gets obscured in how it's marketed. The phrase enhanced service levels appears in the documentation, but what you're actually getting is reduced probability of being throttled, not guaranteed speed. There's also a mechanical quirk worth understanding. Priority tier requests pull from both your committed capacity and your regular rate limits simultaneously. If either is exhausted, the request is declined. So you have two independent ways to get blocked.
The capacity reservation illusion is a good way to frame it. Because compare that to AWS reserved instances, which also don't guarantee performance, but at least the underlying hardware is dedicated to you. Priority tier is shared infrastructure with priority queuing.
And that's a meaningful distinction for enterprises who think they're buying something closer to dedicated capacity. They're not.
What about enterprise tier? Custom pricing, account managers, that kind of thing?
Enterprise tier does include SLAs, but they're custom negotiated and not publicly disclosed. Third-party analysis puts pricing somewhere around $500 to $1,000 per month for 10 to 25 users, scaling to 5,000 to 15,000 or more for larger deployments. You get dedicated account management, priority support, audit logging, compliance APIs, and presumably some negotiated performance commitments. But we don't know what those look like because no one publishes them.
And then there's fast mode for Opus.
This one is genuinely revealing. For Opus 4.6, Anthropic offers a fast mode in beta. Standard Opus 4.6 pricing, $5 per million input tokens, $25 per million output tokens. Fast mode, $30 input, $150 output. That's a 6 times premium specifically for lower latency.
6 times.
And the implication of that pricing is something Anthropic would never say explicitly, but the math says for them, they can deliver faster responses. It's a resource allocation choice, not a technical ceiling. Standard tier latency isn't the fastest they can go, it's the fastest they're willing to go at standard tier margins.
So when your Claude response takes 3 seconds, that's a product decision, not an infrastructure limitation.
At least partially, yes. The existence of a 6 times premium latency tier is an implicit admission that faster is possible. They're choosing to allocate the capacity differently at different price points.
Okay, let's zoom out and do the industry comparison, because I want to know whether this is an Anthropic problem or an industry-wide problem.
Both, honestly, but in different ways. Start with traditional cloud SLAs. AWS EC2 in a multi-availability zone configuration, 99.99% uptime SLA. Single instance, 99.5%. Azure VMs, GCP compute, similar numbers. These are the gold standard of enterprise cloud procurement.
And their latency SLAs?
Don't exist. AWS does not guarantee latency. Azure does not guarantee latency. GCP does not guarantee latency. None of them.
So the comparison to Anthropic's priority tier at 99.5% uptime is actually roughly comparable to a single AWS instance.
On uptime, yes. Which is interesting because a single EC2 instance is not considered enterprise grade. You'd run multi-AZ for anything production critical. But here's the deeper point. The AWS SLA defines unavailable as having no external connectivity. If your EC2 instance is reachable but responding in 40 seconds, that's technically available under the SLA. You have no contractual recourse for a slow response, only for a completely unreachable one.
So the SLA concept, as it exists in traditional cloud, is really just an availability guarantee, not a quality of service guarantee.
That's the structural gap that nobody has solved yet. You can have 99.99% uptime and still have a model that's effectively unusable during peak hours because responses take 45 seconds. Technically available. Practically broken. And no SLA framework from AWS, Azure, GCP, OpenAI, or Anthropic covers that gap.
What's OpenAI's situation?
There's a Help Center article that has apparently been unchanged for years. The exact text is, "We will be publishing SLAs and are working hard to get there." That's the entire answer to whether OpenAI offers latency SLAs. They do have a priority service tier for enterprise customers with SLA-backed latency guarantees, but the specific terms aren't publicly disclosed. And there's a community thread that captures the practical problem perfectly. The title is essentially OpenAI Priority Tier SLA, no way to measure latency. Because even if they promise you something, there's no transparent, observable metric to validate compliance. How do you enforce a latency SLA you can't independently verify?
Which is a genuinely important point. An SLA that you can't audit is basically a marketing document.
The measurement problem and the SLA problem are actually connected. For an SLA to have teeth, you need agreed upon measurement methodology. P95 TTFT over what window? Measured from client or server? Under what load conditions? None of the current offerings define this. Even if Anthropic or OpenAI committed to a latency number, the industry hasn't standardized on how to measure it in a way that both parties would accept.
There's an interesting angle here on Amazon Bedrock, because if you're accessing Claude through Bedrock rather than the direct Anthropic API, does that change your SLA situation?
It potentially does, and this is underappreciated. Amazon Bedrock has its own SLA listed on AWS's SLA page. So if you're an enterprise customer accessing Claude through Bedrock, you may have different contractual protections than someone using Anthropic's API directly. The same model, two different front doors, potentially different legal frameworks. For a procurement team, that's actually a meaningful consideration.
The Bedrock arbitrage.
It's not widely discussed. Most of the developer conversation assumes you're hitting the Anthropic API directly, but for large enterprises with existing AWS relationships and established procurement frameworks, Bedrock might be the smarter path purely from a contractual standpoint.
Let's talk about what the industry actually needs here. Because we've established that traditional cloud SLAs cover availability but not quality of service, and AI API providers are basically doing the same thing. What would a proper LLM SLA actually look like?
The framing I keep coming back to is quality of service SLA as a distinct category from availability SLA. An availability SLA says the service will be reachable this percentage of the time. A QSSLA would say, when the service is reachable, here is the minimum quality of that service. Concretely, that means P95 TTFT will not exceed X milliseconds. Minimum output throughput will not fall below Y tokens per second. And critically, these guarantees hold during peak hours, not just off-peak.
Which is exactly the period when current guarantees break down.
Because the whole value proposition of a peak hour guarantee is that peak hours are when it matters. An off-peak latency guarantee is almost useless. Infrastructure is never stressed at 3 a.m.
Does anyone offer this?
Not publicly. There are rumors that some of the very large enterprise contracts, think Fortune 50, companies spending tens of millions annually on AI infrastructure, have negotiated custom terms that include something like this. But nothing is publicly documented, nothing is standardized, and there's no way for a mid-market company to access this kind of protection.
So the practical situation for a developer team building something serious on Claude is what? What do you actually do with this information?
A few things. First, instrument your application properly. Don't measure from the Anthropic console alone. Use something like Signaz or even Python's time module to capture TTFT and P95 latency from your actual production requests. Build your own performance baseline. If you don't have your own data, you're flying blind.
And that baseline will tell you whether you have a medium problem or a variance problem.
Which changes your mitigation strategy entirely. If you have consistently slow performance, that's a capacity or model selection issue. Maybe you switch from Sonnet to Haiku for latency-sensitive paths. If you have high variance, that's a peak hour infrastructure problem. Maybe you implement request queuing with retry logic, or you shift batch workloads to off-peak hours.
The model selection point is actually underrated. Because if Claude IQ45 is genuinely the fastest model in the benchmark, faster than GPT-41, faster than Gemini Flash, then for a lot of use cases you're paying a latency penalty for capability you might not need.
The latency arbitrage between Haiku and Sonnet is 3.2 times on TTFT in that benchmark. For classification tasks, short-form generation, routing logic, anything that doesn't need Sonnet's reasoning depth, Haiku is both faster and dramatically cheaper. The capability latency trade-off is almost never discussed explicitly, but it should be part of every architecture conversation.
What about the priority tier question? Is it worth it?
The honest answer is, it depends on your failure mode. If your primary pain point is 529 server overloaded errors during peak hours, requests failing entirely, then priority tier is probably worth it. You're buying queue priority, and that's valuable if you're currently getting rejected requests. But if your pain point is slow responses that still complete, priority tier does nothing for you. You'll be at the front of the slow queue instead of the back.
Which is a distinction that should be front and center in how it's marketed, and currently isn't.
The enhanced service levels framing implies performance improvement. The actual mechanism is failure rate reduction. Those are different products.
From a procurement standpoint, what's the ask here? What should enterprise customers actually be pushing Anthropic for?
3 things. First, transparent standardized latency reporting. Publish P95 TTFT by model by hour. Make it observable. Second, contractual CoS SLAs at the priority and enterprise tiers, not just uptime targets, but minimum throughput commitments that hold during peak hours. Third, a measurement framework that both parties agree on before signing a contract, so that if performance degrades, there's an objective way to determine whether an SLA was breached.
None of which Anthropic currently offers.
And to be fair, none of which AWS, Azure, GCP, or OpenAI currently offer either. This is a gap in the entire industry's maturity. We're in a period where AI APIs are being treated as enterprise infrastructure, woven into production systems, customer-facing products, financial workflows. But the contractual frameworks governing them are still at the "we'll try our best" stage.
The available but useless problem. The service is technically up. Your responses are just taking 45 seconds.
And every existing SLA framework in the industry would say, that's fine, nothing to see here. That's the fundamental mismatch between how these products are being sold and how they're being governed.
I think the March throttling announcement is actually the clearest illustration of the governance gap. Not even the throttling itself. That's a legitimate infrastructure management decision. It's the communication channel. An engineer's personal ex-post, not an official announcement. For enterprise customers, that's the kind of thing that triggers a procurement review.
The opacity is a risk vector that doesn't show up in the technical benchmarks. You can have great P95 numbers and still have a governance problem if the company's communication strategy for service changes is, hope someone sees the tweet.
Alright, let's land this. Where does this leave us?
The core finding is that Claude's latency problem is real, measurable, and concentrated in 2 places, Sonnet and Opus during peak hours, and specifically in P95 variants rather than median performance. The tools to measure it properly exist, TTFT, P95, ITL, tokens per second, and the benchmarks paint a clear picture. Anthropic's flagship models are in the slow tier by industry standards. Haiku is a genuinely fast outlier that gets underutilized.
And on the SLA side, the short version is that Anthropic's priority tier is a queue priority product, not a performance guarantee. 99.5% uptime target is the only commitment. No latency, no throughput. And that's actually comparable to the rest of the industry, because nobody offers CoS SLAs. AWS doesn't. OpenAI doesn't. The whole industry is operating on availability guarantees while selling performance-dependent products.
The 6 times premium for fast mode is the detail I keep coming back to. That's not a benchmark number or a policy document, that's Anthropic's own pricing revealing that faster is possible. Standard tier latency is a product decision. And until customers start demanding contractual performance commitments, not just uptime, but P95 latency and minimum throughput under load, there's no market pressure to change that decision.
Thanks as always to our producer Hilbert Flumingtop for keeping this whole operation running. And a genuine thank you to Modal for providing the GPU credits that power the pipeline behind this show.
This has been My Weird Props. If you want to follow along, search for us on Telegram to get notified when new episodes drop.
See you next time.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. prompts. That's the close from sloth